All right, Mr. Ahmed here for 5.7. Our goal for today is to graph systems of linear inequalities. So how do I graph a system? So what's that word system mean? More than one. So we are going to use the same exact process as what we did on the previous lesson. We are going to graph the linear inequalities and shade the appropriate regions very lightly. I usually use some arrows, and then we determine which part of those regions overlap. The overlapping parts make both systems true, or both equations true at the same time, so that is going to be the solution to the system. So I am going to graph the first line in red, and our y-intercept is 5, our slope is -2/1. So first step, plot the y-intercept, up 5. I don't know if I counted right. 1, 2, 3, 4, 5. Yep, down 2, right 1. Down 2, right 1. And we'll continue that pattern across the whole graph so I get it nice and neat. I don't have my straight edge. So, first step, is this solid or dashed? It is solid. So I'm going to draw a solid line here in red. Now, does this one shade above or below? Y is less than, so it shades below the line. So I'm just going to draw a couple small arrows indicating that this one is going below. Okay? My next step is to graph the other line. We're going to do that one in purple. And its y-intercept is -6. Its slope is equal to -1/4. So first plot the y-intercept. It is going to be a dashed line. I guess I'll include that right now. So dashed line because it is not or equal to. We'll plot the y-intercept down 6. And our slope is down 1, right 4. And if I were to go up 1, I'd have to go left 4 to continue that pattern. All right, I really actually would like to get a straight edge for this line. I'm going to pull it out. All right, so on this one, dashed line coming through, draw it in dashed. There we go. And are we going to shade above or below? Y is greater than, so we shade above the line. Above. So in the red line, going down, it can't go past where this purple one is going up. So I would just shade this one region here in the middle, in between the two, because that's where both of them are going to be overlapping. Okay, so this is the shaded region where it's going above the purple, it's going below the red. All these points make both inequalities true. So if I were to pick the point 0, 0, that's one that's shaded, that would work. 0 is going to be less than 5. 0 is greater than -6. So that would be our solutions. All right, got 2 more and then that's it. So again, going to graph the top line in red. M is equal to 1, B is equal to 5. It is going to be a solid line. And let's graph it. So y-intercept up 5. 1, 2, 3, 4, 5. Our slope is 1/1, so up 1/1. Up 1/1. Up 1, right 1. Up 1, right 1. Take out my straight edge. It's a solid line. So here we go. Let's get that as neat as I possibly can. There we go. All right, now is this one going to shade above or below? Y is greater than, so it should shade above. So I'm going to draw a couple arrows above this line, so I know I have to go above the red one. Now, my other line we'll do in purple again. And our slope M is equal to 1, B is equal to -4, and it is dashed. Not or equal to. So down 4, 1, 2, 3, 4, slope 1/1. It appears as if these lines are parallel. They both have the same slope, so they will never intersect. All right. And here we will draw in our dashed line. And this one says y is less than, so that's below. That's going this way. Well, I do not see anywhere in which that these two lines are going to overlap. This one's going above, this one's going below. They're parallel, they have the same exact slope, so they can't intersect. So this one is no solution. Nothing will make both of those true at the same time. All right, our last one. This was a tough one. So you do have the option of using intercepts. You could find the x-intercept and the y-intercept. That'd probably be easier. But I'm going to use slope-intercept form. I'm going to isolate y. So my top line will be in purple. 6x minus 2y is greater than or equal to 12. I am going to isolate y. Subtract 6x from both sides. And I have negative 2y is greater than or equal to negative 6x plus 12. Then we divide both sides by negative 2. When I divide by a negative, again, I have to flip the sign. So y is less than or equal to negative over negatives, positive 3x minus 6. So m equals 3, b is equal to negative 6. And this is a solid line. And it appears as if I will also shade below. Y is less than. So first we will graph the line. So y-intercept down 6. Our slope is 3 over 1, up 3, right 1. All right, take out my straight edge here. Draw a nice straight solid line. Get it close here, there we go. Okay. And this one's going below the line because y is less than. So below is going to be down here. There are a couple arrows going below. My test point is 0, 0. If I picked that, it does not work. 0 times 0, 0 is not greater than 12. So we're going the other way. All right. Now, our other line we'll do in red. So again, I am going to isolate the y. So I have 3x plus 4y greater than 12. Subtract 3x, subtract 3x. 4y greater than negative 3x plus 12. Divide 4, divide 4. Y is greater than negative 3 over 4x. So there's our slope plus 3. Divide both terms. 12 over 4 is 3. M is equal to negative 3 over 4. B is equal to 3. And it is dashed. Dashed line. So plot our y-intercept up 3. Our slope down 3. Right 4. Down 3. Right 4. And take out my straight edge to draw in my dashed line. And we'll see where we're going to shade here. All right, so this one, the red one, is greater than, so we're shading above. Above, so the overlapped area, it can't be here because red's not coming there. Purple is. Can't be over here. This region, red would be true, but purple is not. So we have to shade where both are true, which is this little chunk in here. Shade the whole region. They overlap the shading, and we got it. And that's it for today. Have a good one.